Molar mass, which is also called molecular weight of compounds, is going to be the sum of the atomic masses of all the atoms present. And if we think of the numbers as AMU, atomic mass units, this scales directly up to grams per mole, which is a more useful unit that we use. So let's just calculate the mole mass of a couple compounds, starting with table salt. So grab a periodic table and look up the masses. So sodium is 22.99, and chlorine is 35.45. We add this together and we get 58.44. Barium sulfate, we're going to add up 1 barium, 1 sulfur, and 3 oxygens. We run this through our calculator and we end up with, ooh, let me grab my calculator. And if you look at my numbers here, you see that I like 2 decimal places on my atomic masses in general. The one I like to use more on is hydrogen, which will show up in the next one here. So this next one, copper sulfate pentahydrate. We draw the water out separately. We consider the compound to be copper sulfate, but copper sulfate loves to have water in the solid form, in the crystalline form of it. And we have a number of compounds like this. Some of them will just pull water out of the air to get water into the crystalline form. We heat this up and water comes off rather easily, leaving the copper sulfate behind. So this is showing the hydrate form of the crystalline solid of these compounds. But we include that in the molar mass of the compound. So we're going to have a copper plus a sulfur plus 4 plus 5 oxygens, so 9 oxygens. 5 times 2, 10 hydrogens. And hydrogen is the only one that I like to use 3 decimal places on. As you see, for the other elements, 2 decimal places will give us generally 4 or more significant digits. 3 decimal places here will give us 4 significant digits. So we run this through our calculator, and we end up with 249.70 grams per mole. So the units on this grams per mole are showing what we can convert between. Using the molar mass or molecular weight of a compound, we can convert between grams and moles of a compound. The moles, when we look at chemical reactions, the reactants and products all react in molar ratios. So moles is the central unit of amount of substance that we like to use as chemists. So we're going to practice converting between grams and moles next using our molar mass. So if we have a half a mole of sodium chloride, how many grams? And this is a common type of calculation that you do if you work as a lab technician, if you're making solutions, doing reactions. So we're going to take that 0.5 moles and we're going to multiply it by the molar mass of the sodium chloride. So grams per mole times mole. The moles will cancel off, giving us grams as the answer. So we run this through our calculator and we end up with 29.2 grams of the sodium chloride. You see, I didn't keep 2 decimal places here as I did in the molar masses of the compound. That's because the moles has 3 significant digits, so I only kept 3 significant digits here. So to turn grams into moles, we can't multiply by the molar mass because that will give us grams squared per mole. So we divide by the molar mass or multiply by its inverse. So we have, oops, I wrote SO3 there, SO4 there. Turn this back to a SO3. So we have 217.4 grams per mole. Run this through the calculator. We end up with 0.460 moles of the barium sulfite. So the last one, if we have 0.333 moles of the copper sulfate pentahydrate, how many grams is times grams per mole will give us grams. So we're going to multiply these together. Run that through our calculator, and we end up with 83.2 grams of the copper sulfate pentahydrate.